Our method for persisting sessions is going to be to use, instead of session here, instead the cookies helper. So cookies is a Rails method that lets us put more permanent cookies that last even after the browser closes. And our general strategy will be very similar to the way we currently log users in. Let's look at that here in the sessions controller. So the way we log users in is we find by something unique, in this case the email address, and then we verified that the user exists, that it's not nil, and then we authenticate that user by comparing the password, this params of session of password, with the password digest. This happens automatically inside of has secure password, so this authenticate method does that comparison for us, but in this section we're going to have to write our own comparison. In the case of remembering permanent sessions, instead of the email, we'll actually use the user's ID, and instead of the password, we'll use a string of random digits called the remember token, and instead of the password digest in the database, there will be a remember digest. I mentioned before that this session helper automatically encrypts any cookies that get placed on the browser, but that's not the case with the cookies helper that we're going to use to make more persistent cookies. And in this context, there are four main attacks. The first is to use a packet sniffer to detect the cookies being passed over insecure networks, like a public Wi-Fi network. This might let an attacker grab the remember token, and we've solved that already by using secure sockets layer. Remember, we turned SSL on in production, so this prevents that session hijacking attack. The second attack is to compromise the database that contains the remember tokens, and the way we'll do that is the same way that we protect passwords. Instead of storing the raw remember token, we'll store a hashed digest version. A third kind of attack is called cross-site scripting, which involves putting, say, JavaScript into the site. You could do something like putting JavaScript into the user's name. But remember, Rails escapes out any sort of inserted JavaScript by default. Any tags, in fact, get escaped out. So that's going to be prevented automatically. And the fourth main attack is actually gaining physical control of a machine that has a logged in user. There's no way to prevent that attack in general, but we'll minimize it by changing tokens every time a user logs out. And we'll also make sure to cryptographically sign any potentially sensitive information we place on the browser. In other words, we're going to simulate this behavior of session, which automatically encrypts the cookie. There is a way to encrypt the user ID, which we'll end up using with cookies. So we'll be sure to use that to minimize the chances of someone just inspecting the browser and finding the user's ID. Our basic plan goes like this. We're going to first create a random string of digits for use as a remember token. That's corresponding to the raw password. This is what would be in this context. Then we'll place that token in the browser cookies with an expiration date far in the future to make it a permanent session. And just as we saved the hash digest of the password to the database in the form of the password digest, we'll save a remember digest to the database. Then, just as with session of user ID, we'll place an encrypted version of the user ID, but a more permanent one using cookies. Then when a user comes into the site, we'll pull the user out using the ID. So instead of email, we'll use the ID. And then we'll have an authenticate method we'll have to write ourselves to verify that the remember token in the cookies matches the remember digest in the database. There are a bunch of steps there, but we'll go through them right now, and then we'll actually see this pattern again in lesson 10 in a couple of other contexts. In order to do this, we'll have to add a new column to the database. Let's take a look at the new data model. So remember, we added password digest in lesson 6. Now we're going to add remember digest. And because we're using this parallel structure, that we're using basically the same strategy of a unique ID, in the case of the password, it's the email. In the case of the remember digest, it'll be the actual user ID. We're going to be able to use the same bcrypt machinery that we used for the password digest in the context of the remember digest. So let's run a migration. Oops. Here we go. Rails generate. We want a migration to add the remember digest to the users, so we can do that like this. Remember digest is a string, so we can put that here on the command line. All right, let's take a look at that migration. We have to refresh it here. Here it is. So you can see that we gave Rails enough information to make the full migration. This to users told Rails we wanted to add it to the users table, and then we gave it the attribute and type. So that means we can just run this. We're ready to run it. All right, now let's figure out what we're going to use to create the analog of the password. So this is a remember token, the raw password. This isn't the digest. This is the thing that's actually going to be put on the browser. Let's open up a console. There are a bunch of different possible choices. Essentially, any long random string will work. They don't even have to be unique, because remember that users can have the same password. Like 2 different users could have the same password. But of course, it's more secure if the remember tokens are unique, or at least that the probability is very low that they're the same. So what I'm going to use is something that comes as part of a Ruby library called secure random. There are a bunch of different methods on secure random. You can look it up on the web. But the one I'm going to use is this. There's something called a base 64 string. So base 64 strings are strings of capital A through Z, lowercase a through Z, 0 through 9, hyphen, and underscore. So that constitutes 64 different possibilities. That's why it's called base 64. And the URL safe part constructs a string that's safe for use in URLs, which is really nice, actually. We'll be able to reuse this token in lesson 10 as a result. So this is an example. We can just do a few more. Because there are 64 possibilities for each of these, you can look at the length here. Each of these has length 22, so the probability that 2 of these remember tokens have the same value is 1 over 64 to the 22, which is pretty much 0. Let's make it a float. Yeah, so that's about 10 to the minus 40. So even though they don't have to be unique, they're virtually certain to be so. At this point, we have to decide where to put this token. And because we're going to use this in the context of users a lot, it's actually quite convenient to put it in the user model as a class method. Oops, I forgot to put the comment here, didn't I? Of course, you can see here, we made this user digest for the sake of the user's fixtures here, right? But now we're going to be able to use the same digest to create the hash digest of the remember token. So it's kind of cool. We get to reuse that. We're not going to call this remember token because we're actually going to use this to create different kinds of tokens, not just remember tokens. So this is more general than just a remember token. So this is the same thing I did here. This guy. And now I'm going to give each user a remember token and a corresponding digest in the database. So that's like this. This is a method on the user model. This is for a user instance. This is actually not a class method. This is an instance method. So we'll call this using something like current user.remember, or maybe just user.remember. And so what we want to do is actually give the user a remember token that we'll end up storing in the cookies. So the way to do that is like this. I'm going to assign the remember token. Remember, with assignment, I mentioned this briefly before, you need the self dot, otherwise it just creates a local variable called remember token. Use the new token. And then we'll use the update attribute method. to update the remember digest with the digest, this thing, of the token. We could do this. We could do self dot update attribute, but it's unnecessary inside of the user model to put self dot there. This won't quite work. In fact, this might even cause our test to fail. Oh, I guess we don't actually call remember anywhere, so the test should still pass. But this will not work because, in fact, the user, although it does have a remember digest attribute by virtue of the migration we ran, remember the data model, here, we do have a remember digest, but there's no remember token. Again, this is analogous to having a password and a password digest. So the way we got a password attribute was by using HasSecure password, and that automatically creates virtual attributes called password and password confirmation. But in this case, we have to create that attribute ourselves. And by virtual, I mean it doesn't exist in the database. So the way to do that in Ruby is with attr_accessor. So let's put in an attr_accessor for the remember token. There we go. So by calling user.remember, we'll arrange to endow the given user with a remember token that will exist just in memory, and also create a remember digest that will be persisted until we change it. When we log out, we'll actually set this thing to nil.